Hi, everybody. So, today during our session, I had a few questions, and one of the requests was to show how to do question 1 under changing wave speed. I was also asked to do question 3. Okay, so I'll just solve question 1, and which is this one here. Okay, so I worked it out and I'll explain to you what it all means. Okay, so here we go. Let's remove that. Okay, I'm trying to balance the phone in one hand and talk to you. Okay, so here we go. So this one, it says that the frequency of sound is 1250 hertz and the speed of sound in air is 333 meters per second. However, sound goes from air into water and then its wavelength changes and it becomes 2.2 meters. So that's this one. I was also asked about the meaning of hertz and kilohertz and megahertz, so I'll talk about that as well. So frequency is how many waves go past a point in 1 second. So it's measured, it has two units. One of them is hertz and the other one is per second. A kilohertz is 1,000 hertz, just like a kilogram is 1,000 grams. A megahertz, M for million, M for mega, so a megahertz is 1,000,000 hertz, so 1 followed by 6 zeros. Okay, so question A was to calculate the wavelength of sound in air. So the formula is V equals F lambda. Lambda is the wavelength, or lambda is V over F. So that's your speed in air, and that's the frequency, so you get 0.266. Okay, then the next one was to calculate the time, just using V equals D over T. So fairly straightforward, and you get the time. And then the next one was using the values. What would you suggest about the speed of sound in water? Now, the thing is, the frequency of sound doesn't change whether it goes through air or whether it goes through water. So, however, what does change is the speed and the wavelength. We know already about wavelengths. So we know that the wavelength in water is 2.2 meters, and we just found the wavelength in air is 0.266. So this is a smaller number. So what happens when sound enters water is that the wavelength increases. So if wavelength increases, the speed will have to increase because frequency stays the same. Okay? And then the next question was what do you suggest about the speed of sound in water, looking at the properties of water and air. Now, the thing is, sound is a mechanical wave and the energy is passed from one layer to the other. So, air being a gas, the molecules are spread far apart, whereas water being a liquid, the particles or the molecules are close together in a liquid. Okay, so it's possible for energy to be transmitted faster in water because the particles are closer together. So the speed of sound in water is going to be higher than the speed of sound in air. And then you're asked to calculate speed of sound in water. Now there are many ways of doing it. The easiest one is just use V equals F lambda. We already know the frequency, it doesn't change. And they've given us the wavelength of the sound in water. So just multiply the two and you get the answer. There's also a more convoluted or slightly more difficult way is by using those formula, the other formula with wavelength and speed. Okay, so this is one way, and I've also uploaded the worked out answers on Google Classroom. So that's for this question.